Hi students, today we're looking at the lesson Similar Triangles, and you'll be following along with this video in your book on page 121, and we will be able to get through 121 through 123 today. So go ahead and get your book, and we're going to go ahead and jump right in. So this lesson obviously is called Similar Triangles. So far, we have only been working with congruency. So remember that congruent, oh, that's too thick. Congruent means that things are the exact same, they're equal. So if I have something that's congruent to 5 inches, it would be 5 inches. The other thing would be 5 inches. So in similar triangles and similar shapes, it doesn't always work that way. Okay, so we're going to explain why, but just remember that congruent always means equals, and then similar does not always mean equals. Actually, it rarely means equal. So go ahead and get your book to open to page 121, and we're going to start with Explore on that page. So it says Discovering Angle-Angle Similarity. So it's asking you on section A to use a protractor and a straight edge to draw a triangle. Make one angle 45 and one angle 60. So in that box that's to the right hand side of that page, go ahead and draw your best 45-degree angle. If you have a protractor at home you can use, that's fine. And then draw a 60-degree angle as well. We're going to call this my 45-degree angle right here, and then this one is going to be my 60. And it doesn't have to be exact, you can estimate it. Just make sure you classify which angle is 45 and which one is 60. And then compare your triangle to those drawn by your classmates. Obviously you're at home, so you can't do that. Go ahead and just draw any other triangle in that same box that is 45, has a 45-degree angle and a 60-degree angle. Try to make the side lengths a little bit different. When you do that, or if you do it, you can notice that the angle measurements will stay the same, but the side lengths can change. And we'll go into why this works in just a minute. And then on section C, it says to use the triangle sum theorem to find the measure of the third angle of the triangles. Well, that just means that they want us to find this angle. So 45 plus 60 is 105. There's 180 degrees in a triangle, so 180 take away 105 gives me 75. So I know that this third angle is going to be 75 degrees, and that's going to be the same for both triangles because they both had angles of 45 and 60. So let's go ahead and look at question 1A on the reflect, just based on the triangles we've drawn here together. So if two angles in one triangle are congruent to two angles in another triangle, what do you know about the third pair of angles? What did we find out about these two angles right here? Hopefully you said something like they are congruent or they are the same. So go ahead and write that in question 1A. And for 1B are two pairs of congruent angles. So any two pairs of congruent angles. Is that enough information to determine that two triangles are similar? And again, they're not totally explaining what similar triangles are yet, but we'll get there. Let me give you an example here. This triangle is similar to this triangle. Oops, I ran out of space on my board. Is similar to this triangle. They're the same shape, even though it's a little sloppy, sorry, but they're the same shape and just different sizes. So what this process should have been leading you through is to realize that a 45-degree angle with a 60-degree angle can look like this, and it might also look like this, just a little bit bigger if this was my 45 and this was my 60. They're similar triangles. All that changed is their side lengths, but their angles stayed the same. Okay, and that brings you to the key that's at the bottom of the page, and I typed it in bold here on the screen. It says if two angles of one triangle are congruent meaning equal, to two angles of another triangle, then the triangles are similar. And this is called the angle-angle similarity postulate. Get it? Angle-angle, it's for two angles of a triangle. So if two angles of a triangle are congruent, then two angles of another triangle, then the triangles are similar. So if I say that this is a 90-degree angle, and let's say that this is 45, and then I say that this little guy is a 90-degree angle, and this is 45, you know that these two are similar triangles by what most of the time we call the AA theorem, the AA similarity theorem. And AA stands for angle, angle. There's two angles, and because these two angles are the same measures as these two angles in this triangle, they're automatically similar. Okay, so then if you turn the page and go to example 2, so if you turn the page to example 2 on page 122, they gave you two triangles and they're asking you to explain whether the triangles are similar. Okay, so they give you the triangles. Let me get some more space on here. The triangle with a 41 degrees. Let me just take a minute and draw this. Okay, so here's the two triangles that are in your book. They're not drawn exactly, but they have the same angle measurements. So we have a 41 degree, a 30 degree angle, and then an unknown angle, and then 109, 30, and an unknown. So first, we have to solve for the unknown angles. And this is because right now we don't have two angles that are the exact same measurements. So we can't automatically assume that they're congruent or that they're similar because we don't have two angle measurements that are the same. So take a moment and pause the video and find the third angle of each of these triangles. All right, hopefully you were able to figure out that the missing angle in the first triangle is 109 degrees and the missing angle in the second triangle is 41 degrees. So then if you go down to the words where there's some blanks in it, it starts with because on page 122. It says because blank in one triangle are congruent to blank in another triangle, the triangles are blank. So what we're looking for, anytime we're looking to find similar triangles, we're looking to see if there are any two angles that are the same in both triangles. So there's 109 and 109, and there's 30 and there's 30. So because we know that two angles from the triangles are the same, we can use the angle-angle theorem and conclude that the triangles are similar. So your blanks would say, because two angles in one triangle are congruent to two angles in the other triangle, the triangles are similar. Go ahead and fill in those blanks now. Okay, there's also another similarity theorem that is called the side-side-side similarity theorem, also known as the SSS similarity theorem. And this brings you, or this should remind you of dilations when we were working with dilations. So remember that in a dilation, everything was multiplied by some number. And in order to find the dilated image, it could be multiplied by a whole number, it could be multiplied by a fraction. But no matter what, it was always multiplied by a number. And in the dilation, remember that everything was proportional. Okay, so that's the key to this also with similar shapes. So when you're working with triangles, two triangles, and they don't give you the angle measurements, but they give you the side lengths, you can determine whether or not they are similar based on whether or not they are proportional. So what you do is you take the side lengths. I color-coded these black and red. So you take the side length from one triangle, the black triangle, and then you set it equal, or I'm sorry, you make a proportion with the corresponding side. So this side is in the same place as this side on the triangle. So 6 over 2 equals 3. Agree? 6 divided by 2. So then you do that with each of the sides of the triangles. So you would do 9 right here, 9 over 3. Well, 9 over 3 is also 3. and then 9 over 3 again is also 3 again. So we know that if all of the sides of the triangle get simplified proportionally and they all have the same proportion, then they are similar based on the side, side, side similarity theorem. Okay, so if you use the work that we just did, you can fill in the blanks on page 122. And they're saying that the final answer down there says AC is congruent to BC and DF is congruent to EF. So you do not need to set up a second proportion because the lengths of corresponding sides are blank, the triangles are blank. So because the lengths of the corresponding sides are proportional, the triangles are similar. So again, when they're giving side lengths, you want to check to see if the sides are proportional. Okay, go ahead and fill in those blanks now. I'm going to get number 4 started for us. Okay, so here is the diagram that's on your page, on page 123. And this is when we start attaching word problems to these types of this type of lesson. So the word problem says, while playing tennis, Matt is 12 meters from the net that is 0.9 meters high. He needs to hit the ball so that it just clears the net and lands 6 meters beyond the base of the net. At what height should Matt hit the tennis ball? Okay, so this line right here is where Matt is standing, ED, and he needs to hit the ball past the net that's 0.9 meters high, and it needs to land 6 meters past that net. Okay, so if you look carefully, you can see triangle ABC, and that stands for triangle ABC, and the second triangle is triangle ADE. Okay, there's 2 triangles, and they're inside of each other, and the mathematical term for it is inscribed. When they're inscribed, that means that one triangle is located inside of the other triangle. So when you have a triangle that is inscribed of another triangle, the shortcut rule is that it is always similar. Okay, unless for some reason it's a strange triangle that is like just like this. It doesn't touch any of the sides. But when they share an angle right here, and I'll get into a little bit more of why this works in a moment, but just know that if you see a triangle like this, you can automatically assume that it is going to be a similar triangle. So we're going to skip over a lot of the blanks on page 123 and just follow along in this video. So remember that we need to find out what H is. So remember that we need to find out, we know that when triangles are similar, their side lengths are proportional. So we know that line AB is going to be similar to line AD. Remember, AB will be similar to line AD. So I know that 6 will be proportional to 18, or actually I'm going to make it 18 over 6, so it's a little bit easier. 18 is the whole length of AD, 6 plus 12. Okay, so 18 over 6 reduces down to 3. So I know that the proportion in these triangles is 3. Okay, so if this little side, or this net is 0.9, that's CB. CB is similar to ED. So CB must be, it's going to be something divided by 0.9 is going to give you 3. Okay, so when you figure that out, X will be 2.7. Okay, so that means that Matt needs to hit the ball 2.7 meters high in order for it to clear that path. Okay, so that is the answer to the very end of this problem. However, we will do a lot more practice with this in class. I just wanted to kind of get you exposed to it. Your homework for tomorrow is to do questions 1, 2, and 3 on page 124. I want you to be able to think about number 1 and 3 and be able to answer them. If you struggle with number 2, that's okay. You can bring it to class and we'll do a lot more practice with this. Again, I know that similar triangles is a little bit complicated, but don't worry, we will be going over this a lot more in depth once I see you back in class.